and take a picture of what's up there so you have it. The structure of our test today, we had one. This is the first one, so I'll give a second reminder to it. When you come in, next time we have class, you're going to come in and set your phone up on the ledge. You're going to make sure that you've gone to the bathroom and stuff beforehand. But make sure, please, when you leave, and if this looks familiar to anybody, I don't know if it has, it's whatever, this is the back. So whomever that is, if you know somebody who's missing their phone, it's in here. Make sure you take your phone with you when you leave. That's another thing you probably want. When you come in, you're going to have, there's two sections to the test. You're going to pick up one, the non-calculator part, and at about halfway through, I'll let you know that that would be an estimated time where you should be transitioning into the calculator section. But it's not mandatory by any means. I just need both pieces from you by the end of the period. There isn't any extra time, and I haven't had any issues with time so far. Leave your phone up front, no bathroom. Those are the topics that are covered. I will say this to you because there were some, the first group, the data was very bimodal, and that means that there was two sort of pools of data. There was a large group that scored in, let's say, I think if I looked and cut it up, it was 88% and up. And then there was another section that scored in like the 65 to 75 window. And so I was sitting there looking, and then because I wanted to know why. And again, I'm not looking for excuses ever, and I'm not going to be the one to tell any of you ever that you shouldn't be in an enriched math class. I simply don't do it. All of you, every single one of you, can be successful and should be successful. Let's be honest, you've got me. You won the lottery. The difference is this. I went through and I looked at some of those students who were in that lower group out of the two. And I went through and I see, and this, again, this is what concerns me as a teacher, because you all were the people that I believe a wrong was done to. And it's not that you're bad people by any means, and we don't judge ourselves. Your moral worth isn't connected to what you did on a stupid math test, I can assure you. What I saw that was concerning was I looked at, from that grouping, people's 4-quarter grades from Geo Enriched, and then I looked at what their Regents score is. Now, you don't have to answer this question if you don't feel comfortable. Raise your hand if your Regents exam for Geo was lower than your 4 quarters. Now, what I need you to understand from my perspective is this. Okay, terrific. Thank you for those of you that volunteered. I'm going to say this to you nicely. That never happened. I'll say this, not never. In the last 3 years, so I went through and mapped out my scores. In the last 3 years, I have had 149 kids take the Algebra 2 exam, just short of 1. And 6 out of 149 scored lower on the Regents exam than they did in their 4 quarters. 6. So then I'm sitting there and I'm bouncing around and going, what leads to this? Because that's not fair to you. You're thinking that you're at one place when you're not there. And understand, did they go over how really ridiculously hurt that Geo Reg is? You need like a 39% or something to get a 65, and the bump continues. Like I was looking at some scores that were even, someone had a 94 for a 4-quarter average, got a 71 on the Regents exam, which raw score is a 41. There's no way that you had a 94, no. And it's not me being mad at you, because you don't get to pick your grade. So I sit there and I'm going, what is it? So I make it very clear to you throughout the year, we don't do test corrections. We can always do the corrections, but we don't inflate your mark. You should know by now you have about 7 or 8 graded assignments already, and I think we're on day like 9. You're going to have tons of graded assignments in here. Instead of going through and doing, because then we get to this where we're going, well, can I do extra credit? The answer is no, but then people go, well, fine, you want me to fail. The answer is absolutely not, because I'll give you something better than extra credit. Show me that it's an outlier. In 10 weeks, if I go through and look at your grades, and there are 90s across the board, and 1 grade, maybe 2, that's a 60. Those don't match with how you're performing, and they should be dropped. They're not an accurate reflection of what you know. But if I see 60s across the board and one sporadic 90, which one are you? Are you the 60 or the 90? You're the 60. And it's not to be judgmental of you. Again, understand, I throw everything at you. But I want you to be successful. And one of the things that we need to do collectively is, number one, the grade worshiping. Because somebody in Calc earlier today, we're having a conversation and they go, their question was, I handed back their test, and it said, I think it was like 17 out of 20 or something like that. And they go, is this a 95? You have to ask what your percentage is. You shouldn't. I felt like going through and lowering the percentage just based on that question. Like, how are you in Calc, honey? And you can't figure out your percentage. I'm focusing on the understanding. And if that means you guys get, knocked down in the beginning, so be it. If you get knocked down 99 times, I don't care. That means you get up 100. But understand this difference between the pleading and things that we do. We'll get you there at the end. Every single one of you will be successful. I have no doubt in my mind. Not one. But when I see grades in the 80s and then a 60, or 90s and a low 70s, that to me is insane. My average grade for 4 quarters went up by 6 points. So if you got an 85, your average on the Regents exam was a 91. That's what you need to do. But understand that it comes not from going through and making cupcakes or coming in and doing test corrections or all of that garbage. It's ridiculous. In all honesty, if I didn't think you could do it, those are the things I would do. If I didn't think you people were smart and I wanted to make my job so easy, you know what I do? Oh my God, look at how nice Ben prints. 100% Ben, great, good for you. Oh, let's see. Are you a good printer? Michael, close, 99. And your parents would love me. Everyone would sing my praises. And on the one thing that I can't control, the state exam, the fraud would be shown. I don't, and that's the thing that's so funny. They're like, oh, the tests are so hard. The tests aren't hard at all. Again, I got a girl through last year who hadn't passed algebra or geometry, and she got a 70 on the Algebra 2 exam. She failed the Common Core exam. She didn't get a 40 in Algebra 1 or a 40 in geometry. But she got, and then, by the way, do you want to know what her score was? Because this was before the Common Core with the conversion. She got a 67 that converted to a 7. That's something to be proud of. I don't want you to get handed off to somebody else and they discover you don't know how to add, subtract, multiply, or divide. Struggling here with me, we'll do it together. And you're so lucky because no one is better than me. I mean, it's indisputable how amazing I am in my own life. I am so insanely good, and you are so lucky. And I'm going to get every one of you through. But you have to stop the grade worshiping. Because that's the biggest thing that holds you back. Do you feel less significant as a person? I'll say this. Would you rather have, as your child, a very, very long time from now, would you rather have a kid who had a 90% and who made fun of the kids in the BOCES room downstairs, or would you rather have a kid who had a 40% and help those kids out at lunch or talk to them? Which one? So you get your grade doesn't define who you are. Get over it. You're going to fail tests. And if you're all getting it right, that means I'm not doing my job. If everyone had $1 million, being a millionaire doesn't mean a thing. So understand that. We're going to push you. It happens. The only reason I push you is because I think you can do. And I hope that you rise to the challenge. I'm sure you will. Because I have faith in every single one of you. If you want it, I can guarantee you we're going to get you there. And the day of reckoning is going to be that day when those region scores come out. And you go through and you hear from your friends and they go, oh, I got a 65. I got a 70. You go, God, I got a 94. And I'm disappointed. My teacher yelled at me for getting a 94. That old bat thought I could do better. And I'll trace all of you down. You think I don't know? I know. I know. I still remember your brother's Regents grade. That's how long ago. And that's how good my memory is. He got, if I remember correctly, first time through 78, second time through 84. Because I'm invested in you. I'm invested in you. And I'll tell you right now, even Matt, to me, was disappointing. Because he was very, very smart. Still is. By the way, love that I get a random, and this is why I sit here and, we can complain all you want, saying, oh, it makes it so difficult. Sure. I love it. I didn't have your brother's number. I look down on my phone and I see this little, there's an emoji with like this somehow. Is that right? Is there one that does this? Or maybe it's a class. Oh, this, right. So I get this. And it says, my math grade is a 98.6 at University of Georgia. I could have been real easy and said, you know what we're going to do, guys? We're going to play games all day long. We're going to sit and we're going to watch videos on the computer because, of course, that beats me talking at you. And then we're going to go through and we're going to write about how we feel about things. We're going to come up with an interpretive dance, okay? All of that stuff. Do you want the guy building the Bay Bridge to have done an interpretive dance and had test corrections and all of that stuff? No! I believe in every single one of you that you're better than that. I hope you believe in yourself and have some faith in yourself. So make sure you study. Set high expectations for yourself because you're worth it. And that's why I get frustrated when people are like, oh, I did terrible on it. Sometimes it happens. Get over it. You want your binky? Maybe that's what I'll do. I'll get a whole... Should we get a class set of binkies for all of you so you can have them and you can feel better? Please. That's nonsense. You're better than that. Period. Now, somebody in the other class, by the way, asked, what's a discrete function? So we literally, instead of being, helpless, we said, well, what's a discrete function? All right, so we looked it up. This was the definition on the first web page that came up. Discrete functions are ones that have restricted input values. So if we're talking about whether or not the lines are connected, the number of people in your class, we don't have 28.3 people in here. It would be very awkward if we did. Can you imagine if just, a shoe and a cat maybe and started hopping in, took a seat? How would it hold the pencil? Number of puppies in a litter. All of those things you don't have partial amounts of. That's the definition of a discrete function. And you find it by not making an excuse, but by going through and looking it up if we didn't do it. I don't care what they did with you last year, but we're going to write the ship this year. You have no idea. You have no idea. We left off, let's do, now, and this is another thing, you've got to be able to think and process. Looking at what's there, take a look at number 2. Hands up, please, when you can tell me what your domain is going to be in number 2. I'll wait for 6 of us. We got 1, 2, 3, 4. What do you want to say? Who can tell me what our range is going to be? This next one, hands up please if you can describe for 4, wait a minute, you can describe for 4 what the shape of an absolute value graph looks like. Allegedly you did this before, what do you want to say? Perfect, it looks like a V. Now, think about the inputs that work in this. What inputs will give you an output? Hands up please if you can tell me that. We got 1, 2, 3, what do you want to say? Every single one of them. I can't find one that won't. How about our range? Think about the types of output values that you're going to get. You don't need a calculator. You are smarter than plastic, whether you believe it or not. What do you want to say? Bracket 0 to positive infinity, because the absolute value function, this part, if it's in an equation, will never give you out a negative value. Can it give you out a 0? Yeah. Can a square root give you out a 0? Yeah. Now, questions on that? Let's go over now and take a look at this one. Notice I'm asking about the domain. The domain is the input values, left and right. The range is the y's going up and down. If I need to figure out what the domain is, hands up please if you can tell me one value that is not in the domain. Who can give me one value, please, that's not in the domain in question 5? 3 will not give us an output. Why?
Because the denominator will be 0.
The denominator equals 0. Who can tell me another value that's not in our domain? What?
-3.
-3. So my domain, remember, you can't have a denominator equal 0, so I set it equal to 0, so I get x squared minus 9 equals 0. Add the 9 over, you've got x squared is equal to 9. Take the square root, it's plus or minus 3. Those are the values that x can't equal. Because you can't divide by 0, that's an undefined expression. Now, in terms of an interval, if we need to exclude -3 and +3, what would we go through and do? Hands up, please, and tell me what that interval would look like. We got 1, 2 people, and it's okay. I don't think we've done one like this before, so we may miss a piece of this. What do you want to say?
Parenthesis negative infinity, and then bracket 3.
Careful. As I move left to right, what's the lowest value that's not in our domain? No. 2 is in our domain. -3 isn't. I need to hop over the -3. So I'm over to here. I don't include the -3, but I get right up next to it. And I'm going to jump over it. Hands up, please, if you can tell me what's on the other side. The jump you gave me right now was too big. Can anyone tell me why? Perfect. So what is the missing interval? This means everything I jump over the -3, I resume I jump over. Set the denominator equal to 0 if it's a rational expression. That's what you can't get. How about the next one? What would we go through and say? And this one's going to be tough. Look at 6. Who can tell me a value? Three is not in the domain. Who can tell me why 3 is not in the domain? We got 4 or 5. What do you want to say? Terrific. Can you take the square root of 0? Yeah, but it gives you a 0, right? So we know that there's a transitioning that's going to happen at 3, or when the radicand equals 0. Do the values above 3 work or below 3? Hands up, please, if you can tell me that. We've got one person. Are you kidding me? Do the values above 3 or below 3 work? Let's try 10. 10 minus 3, that's 7, square root of 7. That gives you an output. So if I gave that out, it's 3 and above. What would the domain of that look like if it's 3 and above? Felix, what do you say? Next one up for 7. Jordan, what would you do in 7?
Alright, so you would plug -7 in for x in both equations.
Nope. Remember or no?
Can't remember what.
Who can help us out with what we would do if we are one person? 2, 3. You know? You think? Give it a try.
Don't you plug in the x first, like x squared, and then you figure that out.
I'll plug what in there?
Plug x 7.
Okay, so let's do f of -7. Now, I'm assuming you can do this without the calculator, is that right? What's -7 squared? And then you have to do what to that 49? Now, do you need to borrow some fingers and toes to get this done? Okay, what's 49 plus 6? Okay, what do you do once you get to 55? So let's do g of 55. Hands up, please, when you can tell me what g of 55 is going to be. You're right, you probably should have a calculator. Are you kidding me? Get real. What?
63.
There you go. There's nothing defective about any of you. Nothing. You're very, very bright people. Questions on this? You should love seeing ones like this. These are easy. And the Regents interprets this as a challenging question. Take a look at the next one. We've got these two. By the way, if it's written like this is my h of x and that's my m of x. I could also rewrite this as h with an open circle m. So h following m of x. Which function is getting inserted into the other one for 8a? Hands up, please, if you can tell me which one is going inside of the other one. What do you want to say? That's so terrific. Let's take the m, this whole expression, and everywhere there's an x here, it's going to get plugged in. So if I were to do this, I would say the outside function, replace that x with parentheses. And by the way, get ready, because all of a sudden we're going to become very weak at algebra. We're going to say, okay, can you go further? Look at the numerator. Can you keep going? Look at what do you want to do? No, because it's not negative 2 times that amount. It's that amount minus 2.
Just add the plus 4 and negative 2 can be combined. So 2.
So what's the numerator supposed to be?
2x squared plus 2.
Oh, okay. All over 4. Now I look at that. How did I get what? The 2 at the end?
Yeah.
Because remember, what's in front? Wait, you're talking about where did?
Here you have 2x squared plus 4.
Yeah. Oh, down here? Because I'm only replacing, see that right there? Where that x is, I'm putting this expression. And that's the only place it gets plugged in.
If it's the bottom when you like dropped the 4th and then
I didn't drop the 4th. Do you see see how there would be like a 1 in front here? So we can just distribute the 1 and then we combine like terms. Okay? Thank you for asking a question. I sit here and I look out at you. I wish you would ask questions. Because sometimes I even will put something wrong up there on purpose to see if there's a spark in some of you. Because some of you look at me like you're in a coma. Like maybe sometimes, once in a while, I used to have to say, other people got angry. I used to go around, you know those air horns that make a really loud noise? I had one in the back corner that I hit, and when people weren't paying attention, I would just walk back there and I'd hit the air horn. Wakes everybody up, but then the other teachers started freaking out. Now, we're to there. Why would I be so disappointed in you if you left that? I see this. If that's your final, hands up please if you can tell me why you would be like, I can do more. I got 4 of you. 5. Wake up. What?
UCF.
Of? Okay, so what's left when you divide out the constant?
Squared over 2.
No. You always take it as far as it can go. Yes.
Would you like be divided by 1?
Hang on, I'm sorry. When I couldn't hear what you said. When would I what?
Wouldn't you only divide by 1 and 2?
Wouldn't I divide by?
Like, you know how you divide by both groups, like divide by x squared?
No. The whole expression. See all of these coefficients? And I don't know if this will answer, but I think it will. See how all of these terms have a coefficient of 2 or a common multiplier? If it's a common multiplier, if it's in everything, you divide each individual term by that common multiplier. Okay? And make sure you do it all the way through, because there's going to be some lazy Larrys that go through and try and say, well, I can only do this half and this half, so that's good enough for me. If it's not everywhere, it's not common. Let's take a look now at the other side over here. We need to find m of h of x, or m followed by h of x. Which function is getting inserted into the other? Angela, what do you say?
H is the term.
That's so terrific. We're going to put the h inside of the m. So the h was, what was it?
X minus 2 squared.
Okay.
2 over 4.
So I've got 2 times that squared plus 4, and into that I'm going to put my h. And the other people were like, that's good enough. On what planet? Take a look. The denominator, you can go further. Now you all, you're apprehensive. This is 2 over 1. This is plus 4. What's the denominator going to be when I square that middle fraction? 16. Now, go through right now and tell me what you would get if you took the quantity x minus 2 and squared it, which means you multiply the quantity x minus 2 times the quantity x minus 2. You can use your magic rectangles of fun or whatever the heck they taught you. You could FOIL it or double distribute, I don't care. Hands up, please, when you can tell me what you get when you take the quantity of x minus 2 and square it. I've got 1, 2, 3, 4. What do you want to say?
X minus 4x.
That's so terrific. Absolutely. I write it wrong, I should tell you. Minus 4x plus 4. So far we're great. Can I divide all of these terms by 4?
No?
No, because the x squared has a coefficient of 1. It's not common if they all don't have it. That's the definition of common. The next thing I want to do, though, is I look at this. What operation is getting done between the 2 and that expression? Hands up, please, if you can tell me. What do you want to say? Multiplication. I see something there. You got 1. Oh, come on. 2, 3. What do you see? You could distribute out the 2, but I'm going to make it less work for you. Not cross multiply because there's not an equal sign there.
Just divide the 16 by 2, so you end up with half of that.
You wouldn't say I have 2/16 of that amount. You'd say you have 1/8. So now, when I do that, now I multiply across. These go to 1s. So that leaves me with x squared minus 4x plus 4 all over 8 plus 4 over 1. Well, gosh, if only there was a way for us to add 2 fractions. You're right. In this remedial math class, I shouldn't expect any of you to know how to add 2 fractions together. Are you kidding? Hands up, please, if you can tell me what we need to do to add these together. I've got 1, 2, 3, 4.
Oh, yeah.
We're getting there. What do I need to do to add those 2 expressions together? What would my common denominator be? 8. How can I rewrite 4 so it has a denominator of 8? Hands up, please, if you can tell me that. Oh, come on. We're better than this. We are so much better than this. All right, now I'm going to add. And when I do that, let's cycle across. Oh. McKenna, what are you going to get in the numerator when you go across and you combine your like terms?
I have a different question.
Yeah. Can you answer mine first?
What was your question?
What would you get if you added these numerators going across? Yeah, because that's what you're doing with the fractions. You know it's going to be over 8.
X squared minus 4x plus 36.
Now, what's your question?
Okay,
Since you were nice enough to answer mine.
up there.
Up where?
The 2 over 1 times the...
This right here?
How do you turn that into 8 if you're multiplying by 2?
No. You're taking 2 times the numerator over 1 times 8. What's 2? What's 2 8s? Or sorry, 2 16s. 1 8. Okay. You can reduce before you multiply. It makes the multiplication a lot easier.
Oh, wait, no, I have another question.
Keep going.
If you said you're multiplying across, why did you multiply the numerator by 2?
You could have.
Because you reduced it.
Yeah. We actually, because we reduced this, 2 over 16 is 1/8, and then I multiplied 1 times the numerator.
Oh, and then you would end up taking out that 2 anyway.
You would, if you didn't, you'd get to a bigger answer, then have to reduce it. I think one of you indicated, was that what you were saying to do, to distribute out to 2? Yeah, and you get a bigger answer and then say, then everything has 2 in common.
So you just have to reduce it.
It doesn't matter which way you go. 1, I think, is less work.
So when you divide the 16 by 2, that's making the whole fraction smaller?
Well, you're removing a common multiple, okay? So the numerator and the denominator all are both multiplied by 2. Just like if you had 10 over 2, what's that really the same as? 5. Because what do the numerator and denominator, what were they both multiplied by? To get there, okay? Any more? You won't ever stop me, don't worry. How do we find the inverse in number 9? Hands up, please, if you can tell me. And by the way, notice how little we're going to the calculator. What do you want to say? By the way, let's start off with this. What shape is 9 going to be? A parabola. Is a parabola going to be, or is a parabola going to have an inverse that's a function? No. Can we make it such that the parabola is 1 to 1? Do you remember what it's called? Does anybody remember what we... Restrict your domain, because you're only going to look then at 1/2 of the parabola. You find out where the half is going to be split, and then you would do that. So just know, because there are people that were arguing, they go, "We never. What is this saying?" If I give you a question, is that going to have an inverse that's a function? No. What if can we make that happen by restricting the domain though? Yeah. We can narrow this down so it's 1 to 1. Let's find our inverse, and this should be real easy. We switch the x and the y, so this will be x is equal to 7x squared. Oh, what a dummy, I said it right. Y squared minus 3, add the 3 over. Divide by 7. I'm going to take the square root. Now, since I did not restrict the domain, I have to give both. Since I did not restrict the domain, I have to give both. So I'd say y inverse is equal to plus or minus of the square root of x plus 3 all over 7. Why is it plus or minus? Because we didn't restrict the domain. This is going to be a sideways parabola when we do it. What was your question? You would have partial credit. Because if we don't restrict the domain, if I take a parabola and then I take its inverse, it's going to look like that. And you're telling me the whole parabola would have an inverse that looked like that or like that. Okay? Yes?
If you use a very real reaction, how does it work?
You take the square root of the numerator and the denominator. So the square root of 1/4 would be what, Felix? What's the square root of 16/9? What if if it's involved in solving, it would be plus or minus. But if I give it to you straight up, that's what you'd say. Take a look right now at number 10. What would we do in number 10? Taking a look at what's there, hands up please if you can tell me what you would do in number 10. Oh my. Oh my, we are so much better than this. What do you want to say? There you go. So I take g of -5, hands up please, do not go to your calculators. G of -5, what's its value going to be? We've got 1, 2, 3, 4 of you. Should I give you 100 for good penmanship? Okay. Deanna, what do you say? What do you do next? Oh, too much. Listen, I'll tell you this. The people that I used to work with at the food trucks could do this. No calculator. You would be shocked. It was a crime. They were so good at math. Because if you put it in terms of money, it's real easy. I worked everywhere. We got 4 people, 5, 6, left. I can assure you. I'll say this. I'm me, and I'm so good at everything. Now, take a look right now. We're going to answer some of these questions. I'm going to answer out. Think about the graph. Well, let's start off with A. Some of you are going to need to go through and see a graph. I hope that we can get beyond that. Looking at 11A. What is the domain of 11A? Hands up, please, if you can tell me that. What's the domain of 11A? Look at the question. What is the domain? What inputs will give me an output in 11A? 3, 4 of you. 5. What is your domain? What inputs will give you an output? What are you going to say? Do you put a bracket or parentheses at that? Notice, if I'm asked to go through and give a restricted domain question, If I'm not allowing anything less than a certain value, you got to remember it may be a perfect square function, a square root function. What? Take a look at what's here. This is the only thing that it's going to break down and give you a problem. You can come up by anything by 5. The problem is this number here. Got to be bigger than 0, right? How do we make that happen? Subtract the 8 over, pick those numbers. Okay? Solve that inequality. Hang on. Did you have the same question?
Yeah, well, I was just wondering how they made 8, but I got it.
Because that causes your radicand to be? What does that cause your radicand to be? If you plug in a negative 8. What do you get under the radicand? Yeah. What was your...
How come it's a bracket?
Hands up, please, when you tell me why it's a bracket, not a parentheses. Hopefully we're getting to these stages where you're getting like the new stuff we've been talking about. It's going to click. And the best part is you're going to use it all year and every year from this point on. Yeah.
The negative 8 is included.
Why? Why is negative 8 okay to get?
Because it gives you 0.
Because you can take the square root of 0. And what's 5 times? Perfect. Now let's think about our range. Again, you would have the calculator this year. Next year you wouldn't. What is the range on that? And we think about the types of output values that you're going to get from this. And hands up, please, if you can tell me what you think your range is going to be. Process those inputs. When I plug them in, what kind of values am I getting? You got 1, 2. What do you want to say? You will never get a negative value from that radicand. The lowest that we're going to get was when we plugged in the negative 8, got out of 0. 5 times 0 is going to be 0. Now let's ask this. What's the domain and range of the inverse? I'm not even going to find it yet. Hands up, please, if you can tell me what the domain of the inverse is going to be. Think about what you know about inverses.
You're going to call the square bracket 0, comma, plus infinity.
Who can tell me what the range is going to be of the inverse?
Bracket negative 8, comma, plus infinity.
That's so good. How do you know? Who can tell me how those people knew what those answers were? What I love about that is you incorporated in the other definitions of inverses in there. It's very easy to go through and say you switch the inputs and outputs or switch the x's and the y's. And she said it differently. You said that you think about it in terms of reflecting it over the line y equals x. That's so great. That shows how all 3 pieces you understand about inverses. Now, we can find the inverse of the equation. Let's ask this. Oh, here's another thing. Go into your calculators now. Graph this out, please. Go in, sign in if you haven't already. Put the regular original equation in. Because we're going to go into just making sure that you can take the inverse. So when you do it, you're going to get something that looks like this. Now, do I see enough of this graph? By the way, not mad right now, but what don't I like about this? Now, when we do this out, I want to change what my window is going to be. So we're going to make that happen so I get a better view of the graph. So instead of sitting there and being, and I call them Zoom stupid because you don't engage your brain at all. Instead of doing some arbitrary zoom that means nothing to you, what should you do? You need to go in and say, all right, am I okay with getting a good look at the graph going side to side? Am I seeing enough x's? Yeah. Am I seeing enough y's? Do I need to go lower on the y's or higher? So let's go in, please, to menu. And you can use the buttons instead of scrolling up and down. But press menu. Let's go down, please, to 4, which is going to be our window. And we're going to go to Windows Settings, which is 1, so we're going to take and look at what's going on there. Our X-min and X-max, we said those are terrific. We're fine with that. Our Y-min and our Y-max is what we need to change. Now, we don't see any negative Y-min, so let's change our Y-min to maybe -1 or 0. And how about, let's actually change it to a -1. Yeah. How about our Y-max? Hands up, please. And I don't know. I mean, we've done it 3 times, so I've got a good idea. How high do you want to go? And guess what? If it's wrong, you can go back and change it somewhere else. What do you want to say? Let's try 20. Hit enter. Do we see more of the graph now? That's good for me. That's good for me. So looking at what's there, the domain of that is from -8 out, range is all positives. It works. Now when I take the inverse of this, should it be a parabola? Should the inverse of this be a parabola?
No, because it's not restricted domain, so it's not a quadratic to begin with.
It's not a quadratic to begin with. How can it be one when you take its inverse? And that's what I mean. You guys are honor students. That connection you should be making. If this graph doesn't look like a sideways parabola, how can the inverse look like one? Keep that in mind. That's what we're talking about, the domains. And the domain concept is very, very difficult. Let's go in and let's find out what our inverse is going to be. So if we did this and found out our inverse, I would say y equals 5 root x plus 8. All right, switch the x and the y. So 5 root y plus 8. All right, now I'm solving for y. Jake, what would you do to solve for this y? That's terrific. Who can tell me what we would do next? We got 1, 2, 3, 4, 5. Come on. What would we do once we're to this point? What? So when you do that, you've got x squared over 25 is equal to y plus 8. From here, I'd subtract the 8, and I'd say, now, did it give it as a function, or did it use a y equals?
Function.
So that means my inverse needs to use inverse function notation. That's my inverse, except that's wrong. And most of you won't see why. Why is that wrong? Because it's a quadratic, and that's going to be a parabola when you graph it out. We need to restrict our domain down. What is the domain of this inverse that I need to make sure that I tack on? Because it's not true for all x's. Who can tell me what the domain of the inverse of this is going to be? I've already listed it out on the paper once. Working. Seriously, it should actually already be on the paper. Like it's actually there. What? Oh, sorry, 0 to positive infinity, right? Over that domain. Questions on that? Now, this is more of the same. Take a look at 13a. What operation am I supposed to do in 13a? Or what's the correct setup for 13a going to look like? Got 1, 2, 3. Talk to me, what do you say? So what would you write out? Times? We're going to wait for 8 of you with your hands up that can tell me what this is going to come out to be. 1, 2. Really? Two people. 3, 4, 5, 6, 7. Oh, plus what was it? I'm sorry.
12.
At the end was 12. What was the middle term? Was it 32x?
Yeah.
do we have to do in,
There's not a DCF.
nope. What would we do in question B? What's it asking you to do? There's more than one way you can get the answer.
Well, plug this 7 into the negative term.
More than that, or simpler than that. F of 7 minus G of 7. That's it. F of 7 minus G of 7. Now, you could subtract the two functions and plug in a 7 if you wanted as well. What answer would I get when I take F of 7? Hands up if you can tell me that. We got 1. What?
Negative 32.
For the final? What's F of 7?
Negative 23.
What's F of 7? No.
7 is 20.
23.
Positive 23.
Minus the G of 7.
55.
Oh, 6. Oh, no, it is 55. I can do that.
Now, the next thing that you do is subtract them. And you need to show out those intermediate steps. Some of you will find that out the hard way. If the work isn't there, you're not getting credit for any of it. What answer do we get as our final? Hands up, please, if you can finish this off. What do you want to say, please? Is that what we got? Negative 32? Okay. Now, write the equation of the line that passes through those 2 points. What do you need to know before you can answer this question? Slope. So you need to know slope comes from y2 minus y1 over x2 minus x1. That's going to mean negative 3 minus 1 all over negative 4 minus 5. Your slope is 4/9. Some of you are still not operating on a y minus y sub 1 line. Get over it. You need to be on it. We saw 2 or 3 people that went through and are doing this y equals mx plus b garbage and solving for it. And by the way, not being successful either. So you're using something from 3rd grade and it's not even working then. It'd be one thing if you were integrating it successfully. Y minus y1 equals m, x minus x1. There's multiple answers. You could have y minus, I'll give you the tough one, y plus 3 is equal to 4/9 times x plus 4. You could use the other point if you wanted to. Yes? You need to show the substitution in at a minimum. So I technically don't need that formula. This? No. If the substitution's not in there right, you're not getting points anyway. Take a look at the next one. This one should take you 2 seconds. Hands up, please, when you can answer this next question. I need to give one that's parallel to that given line passing through that point. Done. Here's another one, horizontal lines. What way do horizontal lines go?
Y equals.
They're y equals lines. So again, I graph it out. 2, negative 3 puts me down here. It's going to go side to side like that, so this would be y equals whatever the y value it assumes, which would be negative 3. Now, I think that gets us to the end. You'll see this. There's more questions, obviously, that we didn't do. At the end, or if you go on to Google Classroom and log in, you'll see in there waiting for you is the full answer key to this. Now, we've got a bunch of you to hand back papers. I'm sorry I collect them. We do so much. This is all the work, by the way, that you've done this year, so of course I'm going to have a very accurate sample as to how much you actually know. Hand these out, hand these out. Set them on their desk, please. Thank you very much. Thank you very much. If you don't know who it is, ask around. People are shockingly nice. And if they're not, I'll force them to be. Thank you. Oh, sorry.